The ERCP scope has four main sections. The tip, which is the end of the insertion tube, that's what goes into the patient, the control grip held by the physician, and the signal cable. The signal cable connects to a processor unit that provides the scope with suction, air and water for introducing or removing air or fluids during the intervention, and with electricity for the camera and light in the tip. The processor unit also records the image from the scope camera and shows it on a video monitor. The control grip contains several buttons to control the suction and the air and water supply and to operate the video and its recording. On the grip we also find the control knobs that are used to steer the bending section of the insertion tube, with which the physician can maneuver through the many bends and curves of the human digestive tract. Another button on the grip is used to move the forceps elevator in the tip up and down. On the side of the grip we find the entrance to the working channel. That's a channel that runs through the entire insertion tube and exits at the tip. Through this channel, long and flexible instruments can be inserted and then bent in the right direction using the forceps elevator. This way, the instruments can be brought to the right place to perform all kinds of interventions deep inside the digestive tract without having to make any incisions in the patient's body. Now let's focus on the tip, because that's the place where bacteria are most likely to find a nice and cozy survival spot. The bending section right behind the tip contains a series of cardan joints that can bend but protects all the cables and tubes inside it. The cardan section is covered by a cardan rubber to hermetically seal it. At the end of the bending section, the cardan rubber is connected to the tip with a layer of sealant to make sure that the scope is watertight. The tip contains several tiny, crafty manufactured parts that are protected by the tip cap, a hard plastic cap that is put around the tip. Inside the cap is a metal housing, the frame in which all other parts are placed. To make sure no water or air can leak into the scope, all edges of the tip cap are sealed with a strong flexible sealant, just as the connection between the cardan rubber and the tip cap. On the side part of the tip housing we find the camera and the light source, both covered with a glass window that is sealed with a thin layer of sealant. Underneath the exit of the working channel we find the forceps elevator. We have already seen that the forceps elevator is controlled by a knob on the control grip. But how does that work? Well, have a look at this animation of the mechanism in the scope. By turning the knob on the control grip, on the inside of the grip a steel cable is pulled at. This cable runs all the way down the insertion tube to the inside of the tip, to an area called the actuator area. This area is normally protected by the sealed tip cap and a cover plate also hermetically sealed. In the actuator area, the steel cable is connected to the actuation lever. This actuation lever forms one piece with the actuation axle, which runs through a small hole in the tip housing and through the forceps elevator, which is fixed on the axle. So when the knob is turned, the cable pulls the lever, which rotates the axle and thus also the elevator. Now, if we would just stick the actuation axle through the hole in the tip housing, there would always be leakage around the axle. This would cause patient materials such as stomach contents and blood to creep into the scope. Then, when the next patient is treated, the fluids of the previous patient may leak back out of the scope and into the next patient, which would of course be very unhygienic and dangerous because along with these fluids you could transfer all kinds of microorganisms and diseases from one patient to another. Therefore, to prevent this, there's a small rubber O-ring around the actuation axle that seals off the little space there is between the axle and the hole in the housing. So, there we are, a great piece of engineering design with sophisticated features made to fit in a very small space. And all that technology just serves one goal: healing people who are ill.